Welcome back to 205G objective number 2. Now we're going to look at our overcurrent protection for our capacitor installations. Since we had to upsize our wire because of inrush and discharge current, it also stands to reason that in order for capacitor banks to work properly, we'd also have to upsize our overcurrent protection. And we need to consider two different things when we're thinking about overcurrent. First, we need to be able to protect our wires and the capacitors. And secondly, we need to allow the capacitors to work properly. There's two types of protection that we can use in our capacitor banks, and the first one is designed to protect the capacitor itself in case of internal short circuits. These normally come as a screw-on fuse supplied by the manufacturer that are engineered to allow the proper operation, but still protect the capacitors from bursting under any fault conditions. We need to make sure that we follow the manufacturer's instructions for proper connection and overcurrent protection with this type of. When it comes to the overcurrent protection of our branch circuits, we need to make sure that we are following Rule 26-10, which states that we can have a maximum fuse size of 250% of the rated current. We can always have a fuse size that's smaller, and the reason why there's such a big variance in what our fuse size is this is placed to protect us from any short circuiting, but still is high enough to allow the capacitor to work normally with its inrush currents and discharge currents. If we happen to have, for example, a 30 amp rated capacitor bank, we take my 30 amps, multiply it by 2.5, which is 250%, and we can find that we can have a maximum fuse size of 75 amps. That does not mean I have to choose a 75 amp fuse. Typically, I'd use table 13, select one of the fuse ratings from that table because that is what I can typically get from my wholesaler. So I could choose a 70 amp fuse instead. I could also choose a 50 amp fuse. The idea is to choose a size that is small as possible without creating any nuisance tripping. If we size it too small and it's going to trip up because of the inrush current, then we have to upsize it, and we can upsize it to a maximum of 250%. As a second example here, if I had a 12 amp rated capacitor bank, I'll take my 12, multiply it by 2.5 to come up with a 30 amp maximum fuse size. And once again, I can choose anything from 12 amps to 30 amps, but I want to size it small enough to protect it while it's large enough to avoid any nuisance tripping. Quite often my overcurrent devices, if they are fuse type, they're going to go into a disconnect. And what I need to consider with my disconnects is two different things. If my disconnect is going to hold the fuse inside it, so it's a fusible disconnect, it must be rated to hold the fuse that's been selected. So if I've chosen a 30 amp fuse, it must hold a 30 amp fuse. If I've chosen a 70 amp fuse, it must hold a 70 amp fuse, and I need to select a proper disconnect for that. If my disconnect does not have a fuse in it, so I have separate overcurrent protection, and then I also have a disconnect, then 26-214 comes into place that says the disconnect must be rated not less than 135% of the capacitor current, which is the same as our conductors. If I do have a fusible disconnect, then it's going to be rated anywhere between 135% of my capacitor current up to 250%, which is what I'm going to have as my maximum fuse size. When it comes to what we select to actually enclose our capacitors themselves, there's very little for us to be really concerned with. Typically, capacitors don't produce a lot of heat, so we don't really need to worry about that. So we don't need to worry about any ventilation or anything else of the sort. What we do need to worry about is Rule 26-204, which states that capacitors must be mounted so that no live parts are accessible by unauthorized personnel, which just makes sense because these can be carrying a lot of voltage, therefore we don't want anyone touching the bare terminals. We also have to consider Rule 26-112 Subrule 4, which is very specific to capacitors. If the capacitors are filled with a dielectric liquid, so they're oil-filled capacitors, they need to be installed on the floor with adequate collection pan or curbing. So it can't be within 4.5 meters of any other electrical equipment or any combustible materials, and each capacitor bank has to have a post-mounted fuse in order to prevent any rupture. So if we do have larger capacitors that are floor mounted and oil filled, we need to make sure these extra precautions are put into place so that there's no accidental fires. We've now gotten to the end of part 2 of 205G on fusing and enclosures, so make sure you guys pay attention to this video, Go through the calculations a couple of times until you're comfortable with them, and then you can continue on to part 3.